All right, welcome back. Today we're looking at 2.5 in Algebra 2, and let's have at it. So, 2.5 is graphing linear inequalities in two variables. So, graph inequalities with two variables. Well, that's a simple, all right. So, remember, inequalities are like, less thans and greater thans and less than or equal to's and greater than or equal to's. And I don't know. Let's just go ahead and get started. So, first off, I want to talk about what a solution to a linear inequality is. Uh, an inequality has got lots of solutions. Like think of something like this. Something of some basic inequality, like x less than 4, right? Well, there's not just one solution to that. If this was like x equals 4, then x would just be 4, right? That's what x has to be. But in an inequality format, you're looking at x, like any x value that fits the description here is a valid solution. So 3 would work, and 2 would work, and 0 would work, and 3.5 would work, and 3.9 would work, and 3.9999 would work. I'm sure you guys are understanding the idea. There's an infinite number of solutions to this inequality. All right, this is the solution, but there's an infinite number of x values that you can manually plug in and it be true, right? So solutions to inequalities, and not just linear inequalities, but inequalities in general, are ordered pairs or triples or whatever format you're working with that make the inequality statement true when you plug them into your variables here. So here you've got an inequality statement. You've got 4x minus y is greater than negative 12. So this is asking, which of these ordered pairs are solutions to the inequality? And this ordered pair is 6, negative 5. So what you want to do is you want to plug 6 in for x and negative 5 in for y and see if you get a true statement, okay? So you get 4 times your 6 minus your y, which is negative 5, is greater than negative 12. Is this a true statement? So 24 plus 5 is greater than negative 12, and so 29 is greater than negative 12. Is this a true statement? Is 29 greater than negative 12? Yes, of course it is. That's a negative number, so obviously a positive number is going to be bigger than a negative number, right? So this is a solution, right? And that's because this is a true statement. This is true. Okay, how about the next one? Is negative 3 comma 0 a solution? Why don't you guys try to find that out? I'll go ahead and plug it in. You guys try to plug it in too. Okay, so I got negative 12 is greater than negative 12. Is that a true statement? The answer is no. This is a false statement. Negative 12 is equal to negative 12, so this is not a solution. Right, not a solution. No. How about the next one? Is this a solution? Well, I'm going to plug it in to find out. I get negative 24 is greater than negative 12. Is negative 24 greater than negative 12? Well, no. Negative 24 is more negative than negative 12 is, so it's not greater. So this is false again. And so this is also not a solution. So both of these are not solutions. So if I were to, this is not a solution, not a solution, is a solution. Okay. So now that we understand the basics of what is and what is not a solution to an inequality, let's go ahead and move on. I sincerely apologize, but I definitely want you to write this stuff down. All right. The step-by-steps is going to be important. Uh, Most students like a procedure whenever they're doing a math problem to figure out, all right, where do I begin? What do I do to get to the end? And this is it. To graph linear inequalities, step one, you get it into slope-intercept form. And you can shorten these steps if you'd like. Step one, get it into slope-intercept form. Step two, decide if you use solid or dashed lines. You could just write, I'll underline like the minimum that you could write actually. Solid or dashed line, and then question mark, and then graph, and then use the solid or dashed line, and then test a point and shade. All right, you could just do this. So like 1, 2, 3, 4. So me making your writing a little bit easier, right? So let's go ahead and go through all these steps. First, get it into slope-intercept form. So that's what I'll do right now. Now, I'm going to act like you guys know how to manipulate these. When you're working with inequalities, you treat them just like equal signs, except when you multiply or divide by a negative, and then you flip the sign. All right, you guys remember that? Go back to that lesson if you've forgotten, or look back in your notes if you've forgotten. There's a video waiting for you, all right? It was made specifically for you guys. So you want to get it into slope-intercept form, and that's like where y is by itself. So what I want to do is I want to get y by itself. So you need to move the 4x. So you subtract 4x, and you're going to get that negative, actually I want to do this in yellow. You get negative 2y is less than negative 4x plus 10. And now you divide by negative 2, divide by negative 2, divide by negative 2, and you get that y is not less than anymore. You divided by a negative, so it flips the sign. So y is greater than 2x, because negative 4 over negative 2 simplifies into a positive 2. The negatives cancel, and 4 over 2 is positive 2. And then 10 over 2 is 5, and the negative is negative, right? So it's negative 5. So there is your slope-intercept form. Now, I know it doesn't say equals, but these still mean the same things. That's still slope, and this is still your y-intercept. So I'm going to treat you like you know how to graph things in slope-intercept form, but we'll do that later on. So give me just a second. All right, sorry about that. So step 2, decide if you use a solid or dashed line. Do you guys remember graphing these on number lines? You know, if we were graphing just like y is less than 10 on a number line. Do you guys remember that? You'd have a number line, and you'd have 10 on it, and you'd have an open circle on 10. And the reason you'd have an open circle is because it is less than, not equal to, right? So if it's not equal to, you have an open circle. Well, when you're graphing, the equivalent of an open circle is a dotted line. The dotted line indicates that you are not touching that point, just like the open circle indicated that you're not touching the point. So if you're greater than or less than, you have, I'll use a different color here. If you're greater than or less than, you have a dotted line or a dashed line, however you want to say it, however you want to think about it. And if you were equal to, you have a solid line. Okay, so in our case, what do we have? We have a greater than, so that's going to be a dashed line. So we have a dashed line. All right, so that was the next step. Decide whether you use a solid or dashed line. So that's just using your eyes and looking at the inequality. Then step 3, graph it like it's a regular line, and then use the solid or dashed line. So this is where I was telling you, all right, I'm going to treat you like you know how to graph this. This is the y-intercept, so you're going to go down 5. You're going to start at negative 5. 1, 2, 3, 4, 5. And then the slope is 2, and that's 2 over 1, and so that's up 2, right 1. Up 2, right 1, up 2, right 1, up 2, right 1, up 2, right 1, up 2, right 1. And we need to connect these dots with a dashed line. So you're going to do something like this. Okay. Very good. So step 3 is completed. Now step 4, test a point and shade correctly. Now remember back up here, we had like different ordered pairs that were solutions or were not solutions. And back up here, I talked about how there's an infinite number of solutions for inequalities. So What this line represents, it's the boundary between all of the things that are solutions and all of the things that are not solutions. So one of these two things will happen. Either all of this is going to be a solution and all of this is not going to be a solution. So all of this will not be a solution. Or all of this will be a solution and all of this will not be a solution. All right? One of those two things is true. And right now we don't know which is which. Now, all right, so try to think about that. Either all of these are solutions or all of these are solutions, and we need to figure out which is true. So, we need to pick like an ambassador to decide for all of these points whether it is a solution or whether it is not a solution. So all you need to do is pick out some ordered pair on one of these sides to see if it's a solution or not. Now, the easiest point to test is 0, 0, typically. So this is like my ambassador point for this side of the line. And we need to figure out, is 0, 0 a solution to my inequality? So if I plug 0 in for x, 0 in for y, is it going to be a solution? So I'd get 0 times 4 is 0, so I would get 0 minus 0 times 2 is 0, is less than 10. Is 0 less than 10? Is that a true statement? Answer that for yourself. Is 0 less than 10? The answer is yes. So this is true. So that means that 0, 0 is a solution. So if 0, 0 is a solution, that means all of the points on this side towards this point are solutions. So that means that everything over here is a solution. And what you want to do, you actually want to shade the solution region. So what I've just done, this is me shading that solution region. All of these points are solutions. You could pick out literally any point in this green shaded, and it would also be true. So I've got a point here, point here, point here, point here. If you wanted to manually pick these out, make the ordered pairs and plug them in, you would figure out they are all true. So all of these points here, this infinite number of points, are solutions. Okay? Fair enough? All right, so let's move on. Graph this one. Well, how nice of me. It's already in slope-intercept form. So why don't you guys try to run through those steps and see if these are true, or see if you can graph these. All right, so let's find out. So right now, get it in slope-intercept form. All right, boom, done. It's already in slope-intercept form. Then solid or dashed line. Well, it's going to be a solid line because you are equal to. Next, graph the line using the solid line here. So y-intercept of 6, slope of negative 2/3. So y-intercept of 6, 1, 2, 3, 4, 5, 6. So there's my y-intercept. And a slope of negative 2/3. That means you go in the negative direction for the rise. So you go down 2, and you go right 3. So down 2, right 3. 1, 2, 3. Down 2, right 3. Down 2, right 3. And then you use a solid line. Okay. So far, so good. Now we decide, all right, are all of these solutions or are all of these solutions? And you have to pick a point. And again, I like to pick the point 0, 0. If 0, 0 is not on your graph, it's not like directly laying on top of the graph, like intersecting the graph, you are allowed to use it. So I'm going to test 0, 0. So let's test 0, 0. And we're going to see if that's a solution. So is 0 less than or equal to 0 plus 6? Is 0 less than or equal to 6? Yes, 0 is less than 6, so yes, it's less than or equal to 6. So that means 0, 0 is a solution. And remember, this is like the one point that we're using as like an ambassador for all of these other points that are on this side of the line. So remember, this serves as a boundary line between all of the solutions and all of the not solutions. So if this one is a solution, that means everything else over here will also be a solution. So all of these points are solutions. And there's my shading. And so I'm done. Now, the last thing we're going to be doing is we're going to be graphing, well, we're going to skip this middle one here. All right, we're going to do this one. Graph y is greater than or equal to 4. Do you guys remember what y equal lines are? We had that a couple sections ago, I think, in like 2.2. That was where we had like x equals lines were vertical and y equals lines were horizontal. This is like a y equals line. You want to graph it as if it is like y equals 4. So if you graphed it like y equals 4, that's going to look like this. You go up to 4, 1, 2, 3, 4, and it's going to be a horizontal line across. And we need to decide, is it a solid or a dotted line? Solid or a dashed line? And it is a solid line. And the reason it's solid is because it's equal to. Okay? So you just have a solid line through here. So a solid line, horizontal line. There we go. And then, again, this one you don't really need to test a point, though you could. It's easier to think about it rationally, like try to just reason through it. You're looking for y values greater than or equal to 4. So tell me, you just think about it in your head. Don't even worry about the problem. Do you just tell me a y value or a value big like greater than 4? Can you come up with one? 5, 6, 7, right? These are all y values bigger than 4. So where is y equals 5? Well, it's right here. Y equals 6, y equals 7, right? So those are all values that are greater than 4, and so these are where your solutions will lie. We're not looking for y values less than 4, we're looking for y values greater than 4. Fair enough? Okay, so now we're going to skip this one. Skip. All right, so we're going to come down here. So if y equals lines were horizontal, what do you think x equals lines are? We actually even said it in the last one. This is going to be a vertical line. And it's going to graph like x equals 5. Okay. Then you have to decide solid or dashed line. So why don't you look at the problem and tell me if it's solid or dashed. It is solid because it's equal to. And so you graph it like x equals 5, and that looks like this. 1, 2, 3, 4, 5. The x value of 5, and it's a solid line. Wow, that's not on 5. It's a solid line like this. And then again, try to reason through this. You're thinking about x values less than 5. So tell me an x value less than 5. Like 4, 3, 2, 1, 0, -1, -2. These are all values less than 5. And so where are those on the x-axis? We got 4, 3, 2, 1, 0, -1. So all of these are valid points. So if these are all solutions, and this is the boundary line, that means everything over here is a solution. That means all of these points are solutions. Okay, done. Congratulations, we're done with the lesson. Hopefully you've thought this was not so bad, and if you had any problems, hopefully you asked me questions, and hopefully I got to you and answered them all. All right, so I will catch you on the next one. You got your homework assignment. Have at it.